What if I told you that a single galaxy, smaller than a pinprick in the night sky, just might rewrite the origin of everything? A galaxy so ancient, so bright, and so impossibly complex that its very existence shakes the foundations of modern cosmology. And what if this strange little object is just the beginning? What if the universe is not what we think it is? What if we're living inside a black hole? This is not science fiction. This is MOMZ14. And this is the story that could change the way we see reality itself. Let's rewind, not to the Big Bang, but to the year 2022. At that point, the most distant galaxy ever seen was GN-Z11, discovered by the Hubble Space Telescope. That galaxy gave us a glimpse into the baby universe, but it was just the beginning. Hubble, with its 2.4-metre mirror, pushed the limits of visible light, but it couldn't see the earliest light, the kind that has stretched for billions of years into the infrared. That's where the James Webb Space Telescope comes in. Armed with a 6.5-metre mirror and infrared vision, JWST shattered Hubble's records. First came JADE's GSZ 140 with a redshift of 14.32. Then MOMZ14, reaching even deeper into time with a redshift of 14.44. This wasn't just about how far it was about what it looked like. Tiny, just 500 light-years across, but incredibly bright. It was bursting with newborn stars, like a stellar fireworks show in the first chapters of cosmic history. But something didn't add up. Galaxies forming that early should be faint, simple, and quiet. MOM-Z14 is the opposite. Bright, rich in nitrogen, and there's no supermassive black hole at its centre. Why is that important? Because black holes are thought to regulate star formation and shape galaxies. But here we have a galaxy forming stars like crazy, with no black hole in sight. Even stranger, its chemical makeup. It's not just hydrogen and helium, it has nitrogen, suggesting that multiple generations of stars had already lived and died before MOMZ14. That means galaxies evolved much earlier than we thought. MOM-Z14 is more than just a cosmic curiosity. It's a signal, a red flag waving from the edge of time, telling us something is off. Our models say galaxies like this should be rare, slow-growing, chemically simple. MOM-Z14 is none of those things. So if the rules are breaking down, maybe we've misunderstood the playing field altogether. What if the universe isn't just expanding from a singularity, but emerging from something even stranger? Enter one of the most mind-bending ideas in modern cosmology. What if our entire universe exists inside a black hole? Black holes, after all, begin with the collapse of matter into a single, dense point, a singularity. Sound familiar? That's how the Big Bang started too. In a model known as Schwarzschild cosmology, the Big Bang isn't an explosion from nothing. It's a bounce from deep inside a black hole in a larger parent universe. Our entire observable cosmos, the galaxies, the stars, the laws of physics, could be the inner realm of that black hole. But it doesn't stop there. If our universe began as the rebound from a black hole, then what about the black holes in our universe? Could they be doorways too? Every black hole, each one sitting silently at the heart of a galaxy, might lead to a new baby universe, a cosmic nesting doll of realities, each birthing the next. And here's a wild thought. Maybe only black holes with stable physics can create long-lasting universes. That might explain why our universe seems so perfectly tuned for life. We're here, because we're the product of a black hole that got the recipe just right. But wait, don't black holes crush everything into an infinitely small point? Not always. In extended theories like Einstein-Cartan gravity, there's something called torsion, a twisting of space-time caused by the spin of particles. At ultra-high densities, torsion might generate a repulsive force, one that stops the singularity from forming. Instead of a collapse to nothingness, we might get a big bounce, a rebound that creates a new, expanding universe. Our universe. But wait, don't black holes crush everything into an infinitely small point? Not always. In extended theories like Einstein-Cartan gravity, there's something called torsion, a twisting of space-time caused by the spin of particles. At ultra-high densities, torsion might generate a repulsive force, one that stops the singularity from forming. Instead of a collapse to nothingness, we might get a big bounce, a rebound that creates a new, expanding universe. Our universe. So how would we know if this theory is true? One clue might lie in the spin of galaxies. A recent study found that an unexpected number of galaxies rotate in the same direction. In a truly random universe, we'd expect a 50-50 split, but that's not what we're seeing. Instead, there might be a preferred axis, a cosmic direction that suggests the universe has a built-in asymmetry. If that's real, it could point to some deeper order, maybe even a fingerprint from the parent universe we came from. The deeper we peer into the cosmos, the more it refuses to behave. MOM-Z, 14 shattered expectations. The chemical complexity, the brightness, the absence of a black hole, none of it makes sense under the old rules. And maybe that's the point. Maybe the universe is telling us. The rules were never what we thought they were. Maybe we're just beginning to grasp the true shape of reality. A universe born from a black hole. A multiverse of bouncing bounces. A cosmic cycle where every end is a new beginning. So now we ask, how many more galaxies like MOM-Z14 are out there? How many mysteries remain unspoken in the darkness? And what will we discover next, if we dare to look? What do you think? Could our universe truly lie inside a black hole? Could galaxies like MOM-Z14 hold the key to everything? Drop your thoughts in the comments below. Let's unravel the cosmos together. And don't forget to subscribe to Cosmic Peak for more mind-expanding journeys through space and time. This is your space.